So for this function, for this example for our piecewise, we're going to talk about evaluating, and then we're going to do a graphing example. I just want to make sure we're comfortable with evaluating. So if you look right here for our piecewise function, there are 3 pieces to this function. We have interval 1, interval 2, and interval 3. When you are evaluating, you have to decide on which interval you're using, where it falls on the interval, and then use that piece of the function, okay? So first we're evaluating -3. So if we're evaluating f of -3, I have to decide what interval does f of -3 falls on. What interval does f of -3 fall on? 1. From -3 to -2, this is where it falls. Because it falls on interval 1, that means I'm going to use the equation at interval 1, which is 2 minus x. So it's going to become 2 minus -3. And we have a negative times a negative makes a positive. And 2 plus 3 is 5. That's how you evaluate. Using piecewise. You determine which interval, you plug in, simplify. Determine which interval, plug in, simplify. Easy enough? All right, so I want you guys at your table, y'all are going to evaluate f of -2, f of 1, and f of 2. And then we'll come back together to check to make sure that we got it. And all right, f of -2, what interval?
2.
Interval 2. The reason why it's not 1, is it equal here? No, so that means it's not included on that interval. Okay, but it's equal here, so it's included on this interval. Does that make sense? Remember, you got to pay attention to your equal signs. I'm not equal here, but I am equal here. Yes? So we're going to use interval 2. So that gives us 1 minus -2 squared, which equals 1 minus 4, which equals -3. F of 1. What interval? Interval 2. Because that's where it's equal at, right? Am I equal here? No. So we're going to be using 1 minus x squared again. So that's 1 minus 1 squared, which is just 1 minus 1, which equals 0. Yes? All right. F of 2. What interval does that fall on? 3. It's on the third interval. It's between 1 and 3, right? Between 1 and 3 is 2. So you're using x to the third, which is 2 to the third, which equals 8. 2 times 2 times 2 is 8. Questions, comments, concerns about evaluating piecewise defined functions? A doable situation? Yeah? All right. Now we're going to talk about graphing them, which is why I gave you little graph papers. So you should have your little graph papers. Mm-hmm. And your notes? Yeah. And the real notes? Yes. I'm not going to reinvent the wheel. You know, I'm just going to keep it going. All right. So here, when we're evaluating, we are going to follow 3 rules. We plot our breaking points, which are our intervals where they begin and end. We evaluate, and then we connect, okay? We're going to breaking point, evaluate, connect. Breaking point, evaluate, connect. That's all we're doing. So the first thing we're going to do is our breaking point. So first is our breaking points. Your breaking points are where are the pieces starting and ending. So for this, our breaking points are at -4, -2, 2, and 4. Okay. On your graph for your breaking points, you're just putting dashed lines. So I'm going to go put some dashed lines in. So I have So at -4, I'm putting in a dashed line. You have to number your graph paper. I'm sorry. At -2. Dash line at +2. and then at positive 4. Okay. How do we feel about step 1? Identifying our breaking points. Easy peasy. Okay. Step 2, we're going to evaluate. So you evaluate each function between the breaking points. So between -4 and -2 is this point, right? So we're going to evaluate. If I substitute -4 in, what do I get? What's -4 squared? 16. What's half of 16? 8. So at -4, I'm going to have a closed circle because my gator is full. So I go to -4, go to 8, and I'm going to put a closed circle. Okay, I'm going to do it now at -2. If I substitute -2 in, what is -2 squared? 4. What's half of 4? 2. So at -2, again, it's equal. So it's going to be a closed circle. So I go to -2, 2. Bam. And then you connect. And then you're going to repeat steps 2 and 3 until you've plotted everything. So now I'm going to connect them and go on to the next one. So on my next one, I have -2 into x is just what? -2. Is it open or closed? Closed. No, it's open, sorry. Because my gator he has no Snicker bar. He's hungry. So I'm going to go down to -2. And I'm going to have an open circle. This should have been more curved, guys. I'm sorry. I didn't do a great job of curving that. It's a quadratic. Bad teacher. It's more of a curve because it's a quadratic. All right, and then we're going to do 2. If I plug 2 in, what do I get? 2. And again, is it open or closed? It's going to be open. It's going to be open. So I go to 2. And we're going to have an open at 2. And now I'm going to connect. Okay. I'm not done, so I have to do what? Repeat. So now the last one, we're going to take 2, substitute it in. What's 2 squared? What's 4 minus 4? 0. So at 2, I'm at 0, and it's a closed circle. So I go to 2, go to 0, and close that circle. I'm going to do 4. What's 4 squared? 16 minus 4? 12. And is it open or closed? Closed. So I'm going to go to 4, go to 12. 4, up to 12, and it's a closed circle. And again, it's quadratic, so I'm going to do my best to try to curve it. It's way up there. And that is how you graph a piecewise. Breaking points, evaluate, connect, repeat. Breaking points, evaluate, connect, repeat. Breaking points, evaluate. Okay? For your evaluation part, if it's a huge gap in between, you may want to evaluate another point to make sure that you're heading in the right direction. Does that make sense? Like if it's curving, or these are small gaps, so I didn't have to really do that. But that's piecewise. Questions about piecewise? Questions about either part evaluating? Because we can't evaluate, then we can't graph. So I just want to make sure we're good at evaluating. Yeah? All right.